Hello everybody, thanks for joining. Today we're going to talk about some of the enhancements that have been made to further expand the support of a wider range of machines in the ESPRIT TNG, both for obviously programming and simulation. So the first thing we'll talk about today is right-angled head support. So you might encounter this in like heavy machining, perhaps a machine like the Mazak FJV, which is capable of doing 5-axis, or I should say 5-sided machining, but actually doesn't have a rotary axis on the machine. The way they can achieve this is by having interchangeable heads. And when they do attach the right angled head, they can actually rotate that head around the tool spindle axis to be able to machine the 4 sides of the part. We're going to take a look at that example in just a minute. Another example we might have is we might have like a 3-axis a 3-axis mill, and we might have a head which allows me to do, say, right-angled drilling on my part. And we'll look at that example as well. But first, right-angled head support. How do we actually achieve this? Well, if you look at the holder GDML file, we actually can now include tool spindle axes. And in this case, this example, the first example that we're going to look at, we actually have 2 tool spindle axes, TS1 and TS2, and those are on either side of my head there. And I'll show you how we actually specify that in in the machine tool builder and how we use it inside of ESPRIT. Okay, so now I have my holder loaded inside of machine tool builder, and this is the holder GDML file itself. You can see in the holder GDML I have 2 tool spindle axes defined, TS1 and TS2, and as a child under each one of those rotary axes, so these are just spindle axes, so you define them just as you would any other tool spindle axis. And as a child under each one of those axes, I also have a tool adapter. Okay, so I can then mount my tools onto my holder. And if we then switch to ESPRIT, we can see here's my part inside of ESPRIT. It's already mounted on my 3-axis mill. And the 3 tools that I'll be using here, I'll be using the face mill, which is just mounted in the station as normal using a, say, a Cat 40 holder. Actually, let's check and see what holder we're actually using. Yeah, it's Cat 40. But in the case of my right angle tools, so these are going to be used for drilling either on the right or left side. So if you look at the operations that I have programmed on my part, I have a facing, which will be done obviously by that face mill that I just showed you. And then I have drilling both on the left and right side. And that will be achieved by using my right angled head. So let's just take a quick look here. And how the tools were actually mounted. You can see that I can choose either TS1 or TS2, just like I had defined in my holder GDML. Okay, good. Let's close that one and open up the one on the right. See, this one should be mounted on TS1, and it is. And my operations are already applied, so I program this just as I would any other machine where I was doing multi-sided facing. I have my pocketing suppressed just because I don't want to waste time during the simulation showing the pocketing. But you can see here with the very first operation, it does a tool change. Okay, it faces. Oh, let me slow this down a little bit here. Then when it gets to the drilling, okay, it actually changes the head. Okay, so this would be something that would probably be manually changed. So you might output like a stop code and some instruction to your operator to change the head. And then I can successfully drill on both of my sides. So you can see in this particular case, no changes to the machine itself, so the machine project, were necessary. I just needed to go and define my holder. Okay, so now we have our gantry style machine loaded, and you can see the part has already been programmed. I already have it set up. The fixture is there, the workpiece is mounted. And with this particular machine, we have just interchangeable heads. We don't have any type of rotary axis on the head here. There's no rotary axis on the table. So we're going to achieve the five-sided machining by changing the heads as well as being able to index the head around the tool spindle axis. Before I show you in the simulation, let's just look real quickly at the operations that are programmed. So you can see that I have the top programmed by using this 2 face mill. And then I have the remaining sides programmed using the T1 face mill. If we look at the tool itself, okay, there is my right-angled head using the same tool for all 4 sides. And then with T number 2, I'm just using a simple head, which is basically aligned with my Z-axis. Let's switch over to Machine Tool Builder very quickly, and let's look at the head itself. So similar to the other head that we were looking at our drilling example, we have a tool spindle axis defined on the holder GDML. Now the only change that I had to make to the machine, and actually you may not need to do this to your machine, it might already be there, is if I want to be able to program basically indexing that tool spindle axis around, I need to make sure that I add this to the machine controller and specifically to the coordinate mapping. So I took the tool spindle axis component and then I just basically defined it, and this allows me to now control that tool spindle axis. Switch back to ESPRIT and let's watch the simulation here. So I should note before we watch the simulation that programming this was, again, relatively simple. We'll provide these examples to you so you can actually look at them inside of your ESPRIT TNG. But basically it's the same as programming in any 4 or 5-sided base. Applying the features, the work planes were automatically defined for me, and then you'll notice that I do have rotary solutions here in my machine operation list, because now I can control, again, that tool spindle axis. Start the simulation. Okay, first I'm going to do the top, change heads, do each of the 4 sides. Then of course I can continue programming. I might do some drilling here. I may do some deburring of my pockets, etc. But you get the idea. The next enhancement we'll talk about is the ability to support Tombstone with multiple rotary axes. So these are actually parallel axes that are supported. The inspiration of this came from customers, potential customers and resellers asking if we can support these machines. Now in this particular machine that we'll watch the YouTube video in just a second, this particular machine, the C-axes are parallel to each other on the Tombstone, and they can all be programmed independently. And I'll show you how we program that inside of ESPRIT. So here I have my part already set up. Okay, and you can see that it's basically one part. We look at the setup itself, okay, one part, and then if we look at the machine, you see that part's been placed multiple times on my Tombstone. So I have my machine operation list here. I have my part operation list here. I have my machine operation list here. And let's see how that was. Speed up the simulation. here's the simultaneous portion, similar to what we saw in the video. We switch over to Machine Tool Builder. I have the machine GDML already loaded. And you can see if I go ahead and say hide the machine base here, you can see that my Tombstone is already on the table itself, that I have my multiple C axes defined. Okay, so the actual machine setup is not that much different, just like adding any type of rotary axis to my machine. The reason why we do it right now on the machine level rather than on the fixture level is because this also needs to be properly mapped in the controller file. Remember, just as in the previous example, if I wanted to be able to control the tool spindle axis, I needed to basically add that to my coordinate mapping. Something similar needs to be done on my machine. So here you can see I have to add my coordinate mappings, and then I'm going to have separate coordinate mappings for each of the C axes, because again, these can be controlled independently. Well, that wraps up our presentation today. I hope you learned a lot about the new functionality included in ESPRIT TNG. And as always, if you have any questions, you know how to contact anyone at DP Technology. We'll be happy to help you. Thanks again for joining, and have a good day.